right. I'm mic'd. I can hear myself. Am I on the screen? I am on the screen. We are all here. It is RustConf. Thank you, by the way, for being here, sharing your lovely presence with me here. And thank you to the staff and organizers as well. It's, I mean, having been on the other side of some events, it's monumental, and I am not jealous of the job they do, and I'm extremely grateful for it. If you see an organizer around, thank them. So, who am I? I have an origin story much longer than any of our births. Of course, you all do too. If you aren't thinking about that a lot these days, you might want to it's a fun story, a fun line to draw into the past. But I've been using Rust for about 4 years now. I learned it right around the time I got my first full-time programming job as like a professional software person. So my enthusiasm for Rust has had me involved in this community for that whole time, and it's been a pretty central element of my personal and professional growth. Lots of friends I see in the audience here, you've all been a part of that, and people that I would like to meet afterwards. Hopefully you can be a part of that in the future. So aside from the Rust story, before my current work, I was at this startup building React Native developer tools. And I got pretty nerd sniped by the challenges of GUI application frameworks and being able to iterate on them over time, trying to ship products on multiple platforms. Don't even begin to think about desktop and mobile. And so I kind of have been thinking about it a lot, and I've been working on this project for a little while. And then, of course, the requisite disclaimer, I do work at a tech company who has a very effective and professional PR and marketing department. I am not here as a representative. And a further disclaimer, I'm actually not working on this with my day job at all. I'm very privileged to write Rust for pay, but this isn't what I'm doing. And then another point to keep in mind, I'm almost definitely wrong about really important things. I started this project in part because I wanted to build apps, and I was too picky. So I'm not really a person who builds apps. I see a lot of interesting technical problems here, but I want to learn more from people who do. I want people to have things to use, and I think that that feedback process and even experimentation outside of my work is absolutely necessary for us as a community to do this thing. Which kind of brings us to this thing. I want to write apps in Rust, as I mentioned. I want to give back technology that I build doing that to this community that's been a real support for me. And I have some specific technical desires of how that should work, how those should be structured, what it should feel like, the requisite levels of dopamine. I think that dopamine is an element of application development that is really important to optimize for. Rust is not constrained to a single environment. So if we are sitting here asking ourselves, what do we want from Rust GUI? I think almost every person I've spoken to has had implicitly in their mind, it's going to be awesome and it's going to be cross-platform, and I'm gonna code Rust all day, and then I'm gonna click deploy on GitHub, and it's gonna be on 8 targets. It'll be right? And I mean that's what I want, right? But I want to reuse my knowledge. I want to reuse my tools when I'm in different environments. This is a brief aside. I found that AOL image. This is our world is beautiful, isn't it? Let's just let this soak for a second. This says, discover ideas about blockchain technology, email marketing. Today's email inbox looks significantly different from the AOL inbox of yore. Make sure your email marketing has grown with the times. Tagged with blockchain technology, business innovation, and thought catalog. So that's totally irrelevant. My point about the cross-platform thing, though, is it's these engineering efforts to build something that you can actually use to do that. I click a button and I hit 8 targets with my deploy. They're massive engineering artifacts, coordinated over huge groups of people. The programming experience in this room, if it was all UI developers, we could spend a year or two and crank something really good out, right? You have Amdahl's law scaling with the organization. People are more effort to coordinate, and there's a lot of technology that you have to cover to talk about applications that are visually interactive, right? So this is an architecture diagram. You probably can't see any of the details, that's fine. This is Cocoa, Mac OS's application framework. They've got 2D animations and 3D transforms. They've got OpenGL and their own windowing and drawing tools. They've got data persistence. They've got text layout, rendering, glyph transformations. They've got image processing, rendering, et cetera. They've got notifications, network access via asynchronous I/O, et cetera. Here's some bit from a newer Android Jetpack framework listing. They've got data binding, lifecycle, navigation, pagination, et cetera, et cetera, et cetera, et cetera. And a lot of these things actually have nothing to do with what's on screen, right? This is another interesting example. I'm obviously in this orbit, so it's like it's on my mind, but Flutter is a really cool set of technologies built for basically the like, I want to write a GUI that hits 8 targets at once kind of task. And one of the ways they do that, of course, is by like hiding many details from the platform from you. And I don't think that's very rustic, but it's a really cool project. And this is a nice thing to look at, to just say like, yeah, you really do need all of those things. If you think about each of those lines, that's like 3 crates per box, at least. So you might want to temper expectations if you think that we're going to have like amazing Rust covering everything framework in the future. There is one caveat to this, of course, which is like human civilization has this really big project for making UI. And it has really cool properties, like it exposes a stable public API that's lower level than most applications want to speak. It's been a place for experimenting with different paradigms, but it has limitations. And I think those limitations are fine, right? The web is good, but it's not going to provide like a rich, local data-oriented consumer thing for managing your life for someone on a feature phone, on a cheap device. And the world is made up of a lot of these people, and the web has a difficult time addressing their needs right now. And I think the other unfortunate thing about that is because you can actually make like really cool Rust web stuff, and I've been prototyping initially on the web, is that I'm pretty sure that having our own Flutter equivalent is pretty far off, to the point where I'm satisfied with it personally, at least. I think I should call out some really cool efforts that have been happening. I think Druid and OrbTK and Azul are all really interesting and exciting. I was a little sad to see that Azul wasn't getting as much maintenance effort, but I think these experiments and like efforts and projects have to continue. But when I think, what do I want to build tomorrow? When can I start doing that? They're pretty far off. And I think that there's a different way, but so this is like the hype tribe that we all gathered here for, right? This is aspirational, right? It's a long road. But I don't think we need to have our own big projects necessarily. I think we can eventually, but I think that we can start by focusing on how do we make like a Rust native UI, but using someone else's toolkit, right? Like, can we make this feel idiomatic in the language? Can we make it so that we can collaborate on this together? And I think that, we have some ingredients for pursuing this direction that past communities or past technologies haven't had, We have these things while we also have a really minimal runtime and incredibly cheap FFI. So, if you look at like the libraries not frameworks methodology, I think many of the important ingredients for being able to pull that kind of trick off are here in Rust right now. So my proposal is that, starting, whenever, yesterday or something, that we try to build an authentic, actually rustic UI ecosystem, and that we begin iterating on, that notion without having to build our own rendering stacks and input stacks and event stacks. And we also are in a really cool position with features, and a bunch of other language features allow us to kind of natively express UI concepts that other frameworks have to bring their own special implementation for, right? So I think there's a lot of room here. I think if that's going to work, if we can pull this off, we have to have code reuse, right? Like that's like the basic trick is crates.io lets us reuse code. We have nice APIs, we iterate on them separately, and groups of people can build technology without like central coordination, right? UI is hard because you have so many domain-specific, and when I say domain, I mean really like platform-specific paradigms to navigate. And also just like historically, we've not tried to do it this way. We don't have like UI protocols. There have been attempts, but they tend to get hidden underneath frameworks anyways. So the thing that I'm building is called Moxie. And Moxie is, at its core, a platform-agnostic, lightweight, declarative UI runtime. In other words, buzzword soup. There's a lot of analogies I could draw. I think React is a really interesting thing to think about in contrast to this. Both Swift UI and Jetpack Compose have really interesting kind of parallels, and I'm friends with one of the people working on Compose. I'm happy to say that we're not just copying Compose, but I was really surprised actually to find out after I'd been working on this for months when I talked to him, and once I joined Google and I got to talk to him about it after they'd open sourced it, et cetera. I was really impressed to find out, like, oh, actually, if you want to describe UI in this declarative style, there's a lot of commonality in the problem set for the language. Anyways, that's neither here nor there. On top of Moxie, I'm working on this library right now called Moxie Dom. I have a couple of other bindings in progress that I'm tinkering with, but this is the most mature. It's what I can demo, et cetera. So let's look at an example of a counter implemented for the web in Moxie Dom, right? We have a struct. Structs, fields are like their arguments, right? So the counter doesn't take any arguments. And we have some contents that we're going to show. And the first interesting thing here is that this describes our UI right now, right? The function needs to be able to run at any time and fully explain to the underlying system what should be on the screen. So first is we need some persistent state to stick around in between these iterations of our render loop, right? We're going to initialize that with a default 0. And the type that's returned here is actually like a handle to that state variable. You can update it. You can read from it. The updates are mediated by the runtime, though, to make sure that we have the scheduling properties we need. And then we have some child components that we show. So first we create a text node with the count of the current state variable. And that state variable, by the way, in future iterations, that'll have the new value. And then we make an HTML element with a button, and we give it a type. This, if you had JSX, this would be much nicer. We don't have that yet. And then we have an event handler, right? So when we take an event, we call some closure, and we call that closure passing in this handle to the state variable, the key to the state variable. And so that way, we can kind of knit everything together. And of course, we put some text in it. And then Google Slides transitions make me skip way ahead. So that's like a little code example. The first half of the buzzword soup is worth talking about, right? So like Rust is platform agnostic. We aren't adding platform into the core runtime. We take minimal dependencies. And I think a focus on latency is the other thing here. Because Rust is, we're fast, right? But we can in our software, aggressively optimize for the user experience and have more empathy for people interacting with the software if we have a first-class notion of latency. And the last thing is that I really want this to work in no-std, and it almost does. And then the second half of buzzword soup, declarative UI runtime. Let's just talk about UI runtime, right? So a UI runtime does some basic stuff. It presents a tree of visual items. Input is accepted from some actor, user, whatever. The items are updated. This is done frame by frame as like a unit of discrete scheduling and done in a loop. So you've got kind of an implicit while-true loop outside your app, right? Some frameworks obviously make you write that yourself. So if you have like a traditional UI system that has like model view controller architecture, you might find that you have this tree that you create, and then you write some code so that when events occur, you manually poke at that tree, right? And the tree carries over. Of course, this crowd, I think, is probably well-versed in the evils of persistent shared mutable state. The mutability tends not to be too shared, although you can have fun things when it is. But still, it's cumbersome, and it doesn't let you do what we really want, which is to describe the UI right now, this moment in time. What does the user see? And I think that this is a really interesting framing because it's human-focused as opposed to technology-focused, right? You actually have to do a very sophisticated dance to be able to program like this. But one of the nice things about it is that each item on the screen corresponds to something that you're looking at in your code, right? So one of the first attempts to do the describe the UI right now in completion was the ImGUI type of library, right? So these fully describe the scene on every frame. They run 60 times a second. They take your input. You write very nice, concise code, especially if you're coming from C++ model view controller land. Render some stuff. They can only work if you have a target that takes a GPU vertex buffer, basically, right? You have to actually draw every triangle yourself. And so some really, really smart people came along and were like, we want to do that. I don't know if this is actually the history, but like we're going to pretend this is like a Hegelian dialectic. These people came along and were like, I yearn to write UI code this way, but it's the web. And the web has the DOM, and if I throw away the whole DOM tree every time, I won't get any debugging, and I'll have really janky user experiences if things miss the frames, etc. And so they said, I want to describe this UI like this, but backed by stateful elements, right? These persistent things. And that's where React comes in. So there's a tilde here because React is actually very, very interesting in many of its own ways, and this is a horrible abuse of its like architecture and terminology. But basically, you have a state store, you accept some event, you get state prime because some event, some transition is caused by that event. That gets committed. The renderer, the runtime schedules a new render call, and that generates a tree of virtual DOM objects, if you're familiar with this. Basically, it's like lightweight descriptions. It's a hash map of hash maps of hash maps of hash maps of the strings to write to the DOM, basically, right? So that's all allocated, by the way, if you want to think about the GC performance on that. And then what it does is it extremely cleverly goes and figures out the difference between your description and what's actually out there, right? This persistent state that's storing for you. And so it's kind of, it owns the state, it owns the backing DOM tree, and your code is running in between them, and the runtime keeps them updated, right? So that's kind of like a declarative UI runtime, is it's managing these updates. It lets you do fun things, like you can see here we have Chrome dev tools, like these are divs that are just there from the browser's perspective. They're like any other, but you're writing code that's like, haha, it's fake XML in JavaScript and I'm flying 1,000,000 miles a minute. And I mean, if you haven't written JSX, it actually is like, it's surprisingly productive, is what I would say. And so if this is kind of the status quo, like this is the bleeding edge of here's how you program UI effectively, we can identify our own goals on top of this, right? So Rust is harder to write than JavaScript or C# or Java or other languages, right? Maybe not for me now with having done it for a while, and I think like over time we will continue to iterate on this, on the Rust tax, so to speak. But for right now, we need to find ways to invest that, right? Like if we want to write UI today, we can't wait for next year's language changes. And I think that we have a few areas of strength for Rust for that. One, we're incredibly latency sensitive. All of our resource allocation and instruction happens in band with the logic it executes, unless we explicitly shove it out of band. We, have extreme control over the amounts of indirection we implement, and we're pretty portable. So this is where kind of the direction takes us, right? We want to work directly with these DOM nodes, right? We can hold raw pointers. We're Rust, and we want to allocate only the data that needs to be inserted into them. And we want to do this using some kind of uniform storage, so there's not like a uncanny valley or a cognitive cliff between user-controlled state and then the runtime-controlled state of the host tree. And so ideally, we can just have this happen in a loop, right? And these memoized updates are minimal and perfect, etc. How do we do that? Well, we need to describe trees. Functions, if you squint, execute over time as a tree. Maybe. I mean, you know where I'm going. So I'll show you what we do. We have these functions, and we're going to pretend that when you push the stack frame for that function onto the stack, that allocates a node in the tree. Weird, I know. And then the other thing we're going to pretend is that indent finds our depth in this tree and indents the print line accordingly. Pretty simple assumptions, I think. Anyone confused? Awesome. Here we go. So we enter root. We created a root node stack frame, or we create a node for the root stack frame. And then we go to the first line, and we have a side effectful function. This all looks like normal programming, right? And then A, it's called by root, so it becomes a child of root. And we enter its stack frame. And then we call it side effect. Because this is now a child of root, it has a depth of 1 in the tree, so it's been indented by a couple of spaces. And we pop back out to root. right? This is control flow 101. Do the same for B. Create the stack frame. Has a node corresponding. Has a side effectful function inside. And then we enter a loop. The first one is a child here. Same thing. Second call becomes a child of the same type, but specialized for that index in that loop. And then the same thing, right? So what we end up with is, we call a few functions, and if we had some magical system for observing the creation of those stack frames and recording that data at runtime, we could correlate them together to actually construct this tree. And that's what the topo crate does. So the topo is like the, scary low-level dependency for Moxie. It assigns, runtime identifiers to kind of logical scopes or stack frames of topologically bound functions. It lets you do what I just showed you. And these IDs are unique. So if you're like in a conditional or you're in a for loop, we're tracking the runtime state. So you can kind of just put the calls to these functions wherever. And if you want to get a little more technical, we trace the path through the function topology to the current point and do some hashing along the way, and that gives us this unique ID. And because it's derived from the structural path, right, on each iteration of this loop, that ID is stable. Right? So if I were to query the ID for C sub 1 on revision 0, it would be the same as revision 1, et cetera, et cetera, et cetera. Because C sub 1 I can only talk about it from within that function while it's executing, and it has this stable identifier, right? So you can do fun things like have a hash map of topo ID to blah, and then that's call site specific storage, right? And then this tree has to get managed, right? Like we have to do this in a loop repeatedly. So there's this Moxy Runtime struct. It takes a root function that it calls on each iteration, and it can be woken up by state changes. That's basically it. It provides a memoization store for the for this incremental updates of the DOM stuff. And really what happens is everything is in there. All the stuff you care about. And frankly, you, in this context, is not like an end user. The runtime shouldn't really be exposed by bindings. Like Moxie Dom has a mount call that's totally separate. But this is necessary for being able to speak in terms of someone else's event loop, right? So we can, I have a very, very hacky initial attempt at running this in band with Windows event loop. So you can have React, but not on a separate thread, right? Not literally React. But. So anyways, we create this environment that's scoped to this topology. We run functions within it that have side effects. Some of those side effects might register event handlers that can update our state. That will, when that's updated, it will get scheduled again. There's an analogy here that's worth thinking about. If you're familiar with React, this is basically what if you made React in Rust but only used context and hooks as the primitives? I think it's fun, I think. But also, this means that you can, I haven't done this yet, but you can, like React hooks, imagine an ecosystem of kind of drop-in functions that will navigate this state updating with your runtime for you without needing to explicitly pass things. Now, one trick here is, as I've described it, this happens on every frame, fully allocates the DOM, like mGUI, so it's like React but less efficient. And we want to not do that, right? So we need some strategy for memoization. We already have this call site sensitive tracking of where in the component tree we are. That gives us IDs. We can have global scoped storage that can be reached from anywhere, but where we can only look at things that are corresponding to our area. So you can do things like run a function as long as the inputs haven't changed. And that will be kept around for the next iteration of the loop. So you kind of rendezvous with yourself, with your own code the next time. And you can combine these, of course, right? Because it's just Rust code. So you can have a memo call that captures some variable and will rerun the provided closure whenever that variable changes. You can say, as long as this component is mounted, I want this content to be identical, right? Never rerun this. And the fun corollary here is that if you implement drop on these types, when they're no longer referenced, we GC them from the memoization store. So you have a frame resource collection process that happens after each root call. And this means you can essentially avoid a whole class of I implement a custom will unmount method or did unmount or whatever, right? Lots of lifecycle methods on traits can just evaporate. The state that I pointed out in that early counter example, this is a state cell that is initialized once at that call site, and then it shows back up on subsequent calls. So you can take that handle and send it off to an event callback. That's some kind of primitives. Let's pop out of the brain dump and look at a little bit of code for something that actually might be familiar. Show of hands, who knows to do MVC? Okay, that's herd immunity. I'm going. It's a clone. It's an app. It's very, very simple that people clone a lot in order to demonstrate their framework. So of course, if you're making a new weird UI runtime, it would be a straightforward thing to copy. It has CSS available. That's one of the big things. So here we have a top-level struct. This is our root component, the to-do app. And the to-do app has two main jobs, right? It has a list of to-do items, and it has a filter that applies to those to render them. So we allocate those at the top, and then we enter a topological call. You can have this is like a topological closure, maybe, sort of. We can show an element and add a CSS class and run a child component that's a custom struct. Same with the main section. This is code I copied from GitHub. And then we exit. And crucially, we pass to this topological closure a scoped environment. So it can look up these types in its environment when it's called, right? So we pass this key to the to-dos, like, hey, everybody in this subtree is going to care about the state of to-dos in this application. So now it's provided to all of them. And the same with the visibility filter. And Google Slides is going to make me click 12 more times. But so this is basically, this is the top level entry point of the app. It's we create some state, and then we make it available to our code underneath. Next, I'm not going to go into header, main section, all of those. That would be hilarious, especially since I'm already out of time. So let's look at a to-do list example here. We get our to-dos, get our visibility. We create an unordered list. We filter which to-dos we want to show, and we loop over them. So if you've written collections in other declarative systems, it can be quite baroque. I think this is pretty cool. Also, a filter list is usually something big to build in any system. And we can do a quick demo of how this works. Is this going to play for us? It will. I have a live demo up on a tab, but this is lower risk. So this is really boring. It's an incredibly simple app. It does effectively nothing. I'm extremely overjoyed to have this be the result of the last year of work. Thank you. That was very gratifying. So there's caveat, which is I've been working on this a while, but it's very, 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 very immature. If you want to be a part of this and you want to use it, then send PRs. So right now, the Domnode memoization is work in progress. It's I can keep the whole tree static, but I lose that one thing, and I don't know why. And so there's a little bit of work there. And once that's in place, it'll be easier to extend that to other backing UI systems, right? Because this memoization is very generic, it doesn't know anything about the DOM. I'm not measuring performance in any meaningful way. I do know on my old system a topological function call, creating this ID, the thing you're going to do thousands of times a frame. It's 150 nanoseconds. So it's a Python function call. It's not too bad. With language support, wink, wink, nudge, nudge, it can get really, really fast. Docs and testing, very much work in progress. There's no JSX or equivalent. If Bodle wants to make type HTML emit this, I'd be super happy. There's no cross-platform elements, and I'm not going to attempt them anytime soon, because I think that if you have a Rust system that can describe native UI components with the same runtime and lifecycle, you can abstract over those to get cross-platform components, as opposed to existing cross-platform systems that tend to manage the things directly. And of course, there's nothing that's not shown in the talk. So, we've got some stuff to build. What's next? Lots of stuff. I'm going to build, if anything, an incredibly infinitesimal fraction of it, which is where this comes in. We need one of these to build UI in Rust. Like, if we want to build apps, and we want to do it together, and not be fragmented into a million different little projects, this is what has to happen. So this is the repo. I have a website that I'm working on publishing. It'll be up soon. The QR code takes you to the Discord if you want to come chat with me. I get pinged on every message right now. Yeah, I would. I'd really love to see everyone there. Also, remember, while you're watching this crab rave, this is my representation of the unique historical point we occupy. Right? This is us. This can be us. We have the types. We have the crates. We have cargo. We have whatever this is. So let's do it. Thanks for coming. Really appreciate it.